Hey, everybody, welcome to this next session. We have um, Abi Aryan, um, and she's going to be talking to us about LLM ops. She is a thought leader in the LLM ops space. She has a report with O'Reilly, What is LLM ops, and is the author of an upcoming book as well. She's the founder of Abide AI, and I'm really looking forward to hearing her thoughts on how to operationalize um, generative AI models in production. Abby, take it away.
Uh, Thank you so much for the introduction. Let me actually get started with sharing my slides, and then I'll talk a little bit about myself and all of that stuff. So let me do this. Share screen. Everyone in the audience, do let me know if you can see the slides perfectly.
Slides are great.
Okay. So a little bit about me. Well, I guess enough has been talked about the founder thing, but I've been working in the field for like a couple of years. So pretty much like working on multimodal models, but and the term isn't really called as such. So it used to be like separate computer vision pipeline. It used to be separate natural language processing pipeline and a separate speech pipeline. So that's been most of my work, which is basically doing AutoML work, creating AutoML labeling pipelines. Prior to that, I was a visiting research scholar at UCLA, where again I worked on intelligent agents. And if you want to break that down, that's basically AutoML, emotion recognition, multi-agent systems. So that's more so about the work aspect of things. And currently, I'm working on a book. I just submitted the 5 chapters there. The entire writing will be done by the end of this year. So that is a book about LLM operations. Primarily, I think my main motivation for that was there's way too much hype in the space. People are using large language models for just about every single problem out there, but they're making the same mistake that we really made as machine learning people, not all of us, but quite a lot of us in 2018, 2019, which is like building models for the sake of building models. And I think there has to be that segregation, which is you have to build models that do solve some essential business problem out there, and you can tie that to the business KPIs itself. So that's where operationalizing sort of comes into play, which is how do we think of the entire life cycle of large language models as something which is iterative life cycle, where the team members are not just the machine learning engineers and the data engineers, but it's basically everybody. It's the business people, it's the project manager. How can we sort of create transparency between everybody, so that even throughout the development of any LLM-based application within a company, everybody's sort of on the same page and can have some collective wins. So that's more so the goal or the vision behind writing the book. One of the chapters, chapter 3 in my book, is on data engineering. And one of the reasons I wanted to give this presentation was I don't think a lot of people are talking about how data engineering has really changed with the whole generative AI space. And I don't have a lot of expertise in diffusion models right now. So I've worked very much with older computer vision models, not with the generative ones. But from like an large language model perspective, how has the pipeline changed? So those are the things I'll cover today, which is A, what has changed, B, why data management is hard, C, what does the entire pipeline look like, and fourth, which is the most important part, which is how to get some quick wins or how to optimize your pipeline. So what's changed? Let's look into it. In terms of conventional large language models and LLMs, I think the first difference is in terms of like the data type and source, where on one side you're looking at like entirely structured data. Now you're looking at a lot of unstructured data, and these models tend to do well on unstructured data. There was a recent paper that came out that was testing large language models on tabular data, and they naturally don't perform as good. But again, discriminative models are fantastic for that. Now, our data came from databases, sensors, APIs. Now, I think for large language models, our data sources are basically web scraping, document repositories, archive, or any sort of text APIs. And now, obviously, you have more capabilities, which is now it can be video APIs as well. When it comes to feature engineering, I think this is where, in terms of like the model development part of things, where there has been maximum change, which is there was a very heavy focus on feature engineering. So you basically collected your data, you picked out the right features to optimize for, and then did hyperparameter tuning on top of those ones to create that raw data into features relevant to the problem, and then you optimize for those ones. Now you don't really require any feature engineering, which means basically you're working with raw data end to end. Now that makes it a little bit complicated, not for the machine learning engineer more so, but for the data engineer, which is now the quality of the data, which still is unstructured, becomes a little bit chaotic in the sense like there's way too much for them to manage and to make sense out of. And it's not just, oh, are my features right? Or do I have missing data, or do I have outliers? In fact, outliers and missing data is fantastic right now. So leave them in your data set, especially for large language models. When it comes to data volume and processing, is with conventional models, we were working with very small data sets. So processing was done on smaller traditional CPUs and GPUs. Now, obviously, that's changed, which is you just really, everybody sort of needs GPUs or cloud GPUs, whatever you prefer, GPUs. One of the ways I sort of separate both of the things is, do you have, based on your task itself, do you have a very clear decision boundary for your problem? And does your solution lie within that decision boundary itself? If it doesn't, or let's say if the hyperparameter space of the solution is really big, in that case, just go with generative AI solution. It's a no-brainer in that sense, which is, if you have a large hyperparameter space, then just querying that large hyperparameter space will be very time consuming as compared to us using some sort of similarity metric here, mostly using cosine similarity metric, which most of the vector databases tend to use. So, it just reduces the time to retrieve information, especially when you have millions and billions of hyperparameter space where that your solution can lie into. So that's what I would say would be one key distinction on when to use one model versus another. The standard life cycle of a large language model, or I would call it the LLMOps life cycle as well, puts data engineering on number one. And I mean, it's pretty much obvious because I think we've been saying it for years and years, which is your data quality, your model quality depends on your data quality. So having a really robust data engineering pipeline, which means basically thinking about the design, development, and management of your pipeline, and having an end-to-end infrastructure to support the training, evaluation, deployment of these models is super important. So that is true whether you're using the base models as is, or whether you're doing some sort of prompt engineering or fine-tuning on top of it. So data engineering still stays relevant, though the shape or the form in which it is being presented right now, or the challenges, I would say the challenges have increased exponentially. So what has stayed the same? Well, cataloging is still relevant, versioning is still relevant, governing data, that's still relevant. I think for most of you guys, especially at this conference, would be aware about data catalogs already, but basically you have a systematic way to be able to capture the metadata associated with a data set. Now, one of the things I wanted to bring your attention to is a tool, which, again, I wouldn't say this is the best tool in this space. I don't think there's any best tool I could say it that way, but this is one which is very specific for large language models itself and something that I've been using. So Secoda AI would be one of my recommendations if you're looking to automate data cataloging for large language models. When it comes to data versioning, I think the same tools that we were using in our MLOps space, which is MLflow, DVC, Neptune, they're still pretty much relevant. I mean, although you may still be versioning more high quantity of data, and there's more, the life cycles of data engineering are much shorter now. but still the same tools are still pretty much relevant. The next question is, does the use case matter? Which is, now, how would my data engineering pipeline differ if, let's say, I was using the model as is, versus if I was doing prompt engineering, versus if I was doing full fine-tuning of the model, versus if I was just building up a RAG application. So let's say if you're training your model from scratch, this is what your data engineering pipeline looks like. You're doing some sort of data ingestion, then you're doing pre-processing, then you're doing sharding and model training. So sharding is basically when you divide your large data set into smaller chunks, and this becomes pertinent, especially for like when you have large data set that you're trying to train from scratch. When it comes to RAG pipelines, you have two separate pipelines, one for retrieval, one for generation, and the same is true for the evaluation side of things as well. Although I don't think a lot of people do it that way, but at least I've been doing it that way and it works really well, which is having separate retrieval metrics, having separate generative metrics. So on retrieval, you can look at scores like your very typical MRR scores, your recall precision, and all of those things. On your generation, you can look at very similar metrics, your n-gram metrics, which is your blue scores, your rogue scores, or you can look at your SEM scores or mover scores, the similarity metrics itself. So you'll have two pipelines for data engineering for both aspects, and you'll have two pipelines which work parallelly with them for evaluation itself as well. When it comes to the retrieval pipeline, you're basically focusing on building a retrieval model. And here, you really care about the quality of the data set itself. When it comes to the generation pipeline, although it is very similar to while you're training the model from scratch, but here, the only thing that differs is your retrieved documents are fed along with a particular context which is provided when you're labeling up your dataset itself. So that is provided alongside the user prompt for the generative model. This can sort of this is more like the optional side of things, but this can actually improve the factual accuracy and coherence of the model itself. And this makes fantastic metadata to be able to store with every single prompt as well, which you can use a cataloging tool for, or you can just use, I don't know, CSV files for. It totally depends on you, not recommending to use one toolkit over the other. The third thing is prompt engineering. Let's say if that's your application. Well, your data pre-processing pipeline is minimal, which is there's not much. You may be collecting about 50 pairs of datasets, but that's pretty much all, which is you have the prompts, you have the document, and then you're constructing your prompts accordingly. And then you're doing inferencing on top of it. So this part one, prompt engineering pipeline looks pretty simple. There's not much work to be done in terms of data engineering for that, other than creating the prompt instruction dataset. When it comes to fine-tuning, here it's more similar to training the model from scratch, which is you have to, again, think about the sharding and vectorizing everything, because, again, you're trying to, and then other part which becomes more relevant here is the versioning of things and making sure you have automated pipelines as well for evaluation on this part of things. So another thing, maybe I don't know what background everybody is from, but for large language models, you're not always fine-tuning the entire model, which is you're not updating all of the model weights in a single go. What you're essentially trying to do is you're trying to update only some of the weights because these models are big, so it doesn't really make sense. It's way too computationally expensive to be able to update all of the weights. That's one of the reasons it's called parameter efficient fine-tuning, or the LoRa and QLoRa techniques that you've already heard about. What are the things that stay same across all pipelines for each of these use cases? Version controls remains the same. You still need to monitor, you still need to evaluate your pipelines. In terms of tooling, the two old tools that we were using in MLOps pipeline, they still stay relevant, which is DVC and MLflow. But the one that you choose to use is totally up to you. Give me 1 second. Now, when it comes to choosing the versioning tool, well, I think you can use any of the versioning tools out there. Some people go with the bare minimum, which is if you're already working with Databricks as your core data lake, then you can simply use git pull and git push. Or if you're working with S3, Azure, or something like that, then you can do DVC. I always tend to use DVC, but again, totally up to you. If you want to use a cloud-based solution, or if that's something you've already subscribed with, again, totally up to you. Now, this is the part which is everything's the same. What then the question is, what has really changed other than the fact that there's one additional thing called prompt engineering? Well, a lot has really changed, and I'll tell you what those things are. So it's these 9 questions to which there is no right or wrong answer. I mean, probably there's a wrong answer, but there's no definitive answer on how to address this. So for example, the first question is, what kind of data composition is ideal? This is a question I get asked a lot for my consulting clients, which is, how do I make sure that this data set is sort of ideal for my particular use case? I'll talk more about all of the work that is going into this space and how to think about these problems itself. But for now, let's just look at the questions one by one. The second thing is, what kind of scaling law applies to you, which is basically, how do I maintain the data versus the model, which is, do I increase the size of the model while keeping the size of my data set the same, or do I increase the size of the data set while also increasing the size of my model? How much repetition is acceptable? So one of the things that almost everybody's aware of is large language models are sort of notorious for memorization. Oh my God, I lost my voice too much today. But one of the techniques you use to be able to deal with memorization is data deduplication. Now, data deduplication, although sounds like just one term, but there's a lot of techniques for deduplicating your data as well. Which of those techniques do you use? And again, how much data do you leave in to be able to improve the performance, and how much data, what are the parts of the data that you cannot repeat? What techniques do you use for data quality filtering? So this is basically like the bias and toxicity filtering. And why do you use those ones? What models do you use to remove duplicates? How do you handle toxic bias data? How much data diversity is needed? How to craft the best prompts for synthetic data generation? How to monitor data aging? These are all questions that are new, not to everybody, but for people who've worked with just conventional machine learning models, small scale models, these questions are new. And more so because of the nature of these generative models as such, which is there's not a lot of explainability within these systems itself. So your standard pipelines looks pretty much the same, which is you're collecting the data, you're pre-processing it, you're storing the data somewhere, hopefully in this case in vector databases. And then the final thing, once you've done all of this thing, you're thinking about, how do I keep my data fresh? But if we look further into this, which is, there was this paper, I'll leave a link to the paper. It's in the speaker notes itself. So I'll give you the link to these slides itself. But there was this paper that created this really amazing figure. And what you have is, what you're looking on your screen is basically data management pipelines. For case one is if you are training the model from scratch. And the second one is if you're fine-tuning the model for or you're doing any kind of domain adaptation. That could be fine-tuning, that could be just a RAG-based system, that could be a prompt engineering system. So the first part of a data management pipeline now is data composition. That's the hard thing, which is, how much web data do I need? How much Wikipedia data is okay? How much code data is okay? And what's the ratio I should maintain? When it comes to data quality, this is where we were talking about scaling laws, which is, how do we maintain the data size versus the model size itself? How much repetition are we okay with? Then once you pass this stage, then you go into quality control stage, which is, now you're basically applying some evaluations and stuff, and you're looking at, do I need to scale up or do I need to scale down, or what are the different patterns that I'm seeing? If you're training your model from scratch, then there's obviously a lot more work in terms of diversity and age, toxicity filtering, deduplication, quality filtering. And then eventually you have your final data set, which in the first case would be the pre-training data set, in the second case, which is basically your instruction data set or your fine-tuning data set. And you use that to be able to fine-tune your data set. So that's what the data management pipeline, this is the part which needs to be automated now. So let's talk about domain composition. Why is it hard? Well, I mean, I would say initially, people were using web pages, Wikipedia, and everything. But slowly, what really happened was more and more people started testing out if just using coding data was able to improve the quality of or was it able to improve the quality of your model itself. One of the key reasons for that is, a lot of coding data is basically semantics, and if it is able to learn the semantics of a particular language without understanding sentences and still understand the context, then generally speaking, those models will tend to perform better in a general scenario as compared to if you have a lot of complete sentences which are perfect. So for that reason, there was a shift from collecting high diversity data set to just collecting coding data sets. And while most of this was done in terms of I don't think there's an actual paper that says why, technically speaking, this is a better approach, which is having more coding data in terms of your data set is a better approach. It's basically intuitive reasoning that's been applied. And the actual ratios that people look at is very much like just experimentation itself. So I would say, although there are some techniques right now that have methods for assigning domain weights to be able to target certain distributions that we want to target. But again, most of those haven't really been implemented in the companies that we're looking at. I mean, other than a few, the top ones. When it comes to scaling laws, so one of the first scaling laws that came out was by Kaplan. And what it basically said was the model size and the training data set size should increase roughly at the same rate to be able to maintain the performance of the model. But then later, 2 years later, there was another scaling law that came out by, also called as Chinchilla scaling law, which basically explained that the model size should increase faster than the training data set size to achieve the best performance. So right now we're at that controversial point where you could use either of the laws and decide how big your data set would be in comparison to your model. But again, this is one of those things to which there is no definitive answer on, in terms of the scaling law that came out earlier hasn't still been disqualified. It still exists with its own name. A lot of people picked that one. A lot of other people picked the new one, the Chinchilla scaling law, for their own intuitive reasons again. When it comes to data repetition, basically anytime you're repeating your data, you will have diminishing returns in terms of the model performance. That's the intuitive reasoning, right? However, recently there have been some techniques basically that show even if you keep on increasing, even if you keep on repeating the data, you can apply some regularization techniques, which will prove to be beneficial. So that's more so on data repetition. When it comes to data quality, although the more common techniques everybody is using in the field is quality filtering, deduplication, toxicity filtering. I don't think a lot of people are that much focused on data diversity, and I think we addressed data diversity in the first point itself. But when it comes to the age of the data, again, that's a concern which we can address simply using a versioning tool itself. So there are different methods to be able to think about data quality as well. One is you have the n-gram classifiers, which is basically token-based, very small classifiers that you use to be able to maintain your data quality. And other is basically you use an existing large language model to be able to do that, to be able to filter out the toxic data sets itself. So there are a couple of benchmarks that are available that you can also use. But the downside of using any sort of benchmarks is A, they're not really updated in real time, which means if something was worked on 2 years ago, it might not be super useful right now. The second thing is there's also like a risk of marginalizing minority groups in data. If you focus too much on data quality and if you don't really, because again, I mean, it's one of those questions, which is, do I maintain the data quality or do I maintain the data diversity? It's very hard to be able to come to a balance between both. So I would say these are three big things, which is this is the three big dilemma within the space right now, which is how do I maintain my domain composition versus my data quality versus my data quantity, and how do I optimize them so that I can optimize my computational budget without necessarily compromising in one of the spaces to the extent that it affects the model performance in the long run. So I would say this is more like a full-time job to be done, because again, there's one person whose core job has to be this. So this is where there's a rise of data ops engineer. Although I think data ops has been a term that has been coming up since, I think at least I've been hearing it since 2018. Though I'm pretty sure the term has been here since much before that. But the data ops engineer is somebody who sort of sits between the data engineer and your data sets itself, so your infrastructure and your data engineer itself. And their job is now to be able to do much of the tasks that data scientists were doing. But again, the existing data scientists are not, again, the right people to be able to clean up these data sets either. It has to be done by somebody who's specialized with an understanding of certain kind of skill sets. So that's they need to have very good understanding of how to go about global deduplication, what are the different techniques in this one, why to choose one over another, how to be able to dynamically select the data to be able to do continuous fine-tuning. And then there's more things, which is what are the things that we need to think about in cleaning itself, how to automate those pipelines. So that's where there has been a change. And while I mean, it doesn't really take away from the job of a data engineer itself, but I think data engineering as a domain is expanding, which is if earlier the work on a data engineer was just like 20%, now that the work in generative AI space within like a data engineering profile is like a massive chunk. I would say 50% of the work, which was earlier like distributed to data scientist, machine learning engineer, MLOps engineer, now that falls entirely on your data engineer. So there are two roles or two people that need to constantly support each other in this process itself. What are the big challenges? Or why do we need one specific person to come in and to understand these things? Which is one is there's not an existing general framework for managing data that works for different applications. So this person ideally is somebody who can figure that out, and within every single company, they will have one framework that works for them. So that's one. Second thing is multimodal data engineering is extremely hard to do, but there isn't enough literature in the field as well. So again, open space for a lot of people to work in. How do you handle synthesized data and maintain the ordering of fine-tuning data? This is another one of those things that do impact the performance of a model itself, which is in what order is your fine-tuning data, which is which batch is being given at what point. Otherwise, the machine learning engineers cannot really optimize the performance of your LLM without figuring that out. So this becomes, again, the job of a data ops engineer who maintains it and maintains the ordering and maintains the data essentially, and the modalities of different kinds of data. Also, multitask learning is still, if you have, let's say, conflicting data, if your data says one thing, another set of data says another thing, then how do you deal with that? Is another problem that needs to be addressed. But if the LLM engineer, like the machine learning engineer, is really focused on solving all of these things, then ideally it's way too much work for them. So somebody else has to sort of take up this work. And to me, at least the way I understand it, that person would be a data ops engineer. Now, I think enough about what the role is, what the challenges are. Now, let's say you're in this role. How can you get some quick returns, which is what are the quick things that you can do to be able to optimize the performance of your LLM pipeline itself, or your model itself? First thing is focus on data cleaning, and second thing is implement techniques on deduplication itself. So when it comes to data cleaning, I would say there are 9 core rules. First thing is assess the completion of sentences. If a sentence is incomplete or doesn't really make sense semantically, remove it. Second thing is remove any sort of privacy, personal private information, PPI information, remove that. Delete any sort of harmful content, pornography, and all of that stuff. Get rid of abnormal symbols. So anything which is at and the binary symbol, those need to go away. That's just noise. Remove the technical clutter. So any sort of identifiers from HTML, CSS, JavaScript, they need to go away. Delete sentences with curly brackets if there are any. If they're very short sentences, delete them. Remove all of the redundant content and get rid of text with the unwanted words, which is now I would probably say these are not recommendations for a large scale team. These are recommendations for if you're building your own application, you're one person who's trying to do everything by yourself. And then you're focusing on how can I get my 10% performance boost? What are the things I can do with in terms of like the data set that I've picked up from Hugging Face itself? What are the things I can do with that data to get a better model itself? These are the things I would probably suggest. When it comes to deduplication, there are 4 approaches. Though there are a couple of them, but there are 3 main ones which are used. So the first one is DF-IDF soft deduping. What you're essentially looking at is the frequency of words in a document as compared in a text as compared to like the entire document. And if there are 2 texts that share high similarity based on their TF-IDF scores, then you ideally remove one of them. So basically, in a way, what we're saying is if there's any sort of linear, or you could compare it with linear dependency between data sets, if any part of the sentences could be regenerated based on something else, or if it looks similar, then just remove it. What that does also is it increases the weight, which means there's a very good chance, especially like if you're implementing a RAP pipeline, then you might have a chance of retrieving that faster as compared to getting a more accurate response. The second thing is min-hash. So this basically is a technique to estimate how similar 2 text of sets are. So this is really useful when you're doing any sort of copywriting work, or if you're checking for plagiarism and all of those things. Again, can be really helpful also for very quickly checking if you have inconsistencies within your data as well. So for example, when it comes to financial data, you ideally do not want inconsistencies within that. So that's where it's really helpful. When it comes to SimHash, what this does is basically turns your text feature into a fixed length hash code, which now measures the similarity by sort of seeing how these hash codes are sort of how farther are they from each other. So very much like how cosine similarity works. The closer the codes, it means they're basically more similar the text. And then you can safely remove that text, the one of those texts, to make sure that you don't retain a lot of similar copies within your data. And one of the key reasons, again, we're doing this is to be able to reduce memorization in the model itself. What else can be done? I mean, beyond this, if you're just looking to build something, then integrate it with real-time data feeds, segment your data into context windows as much as possible. So, figure out what your HFT strategy is, whether you want to segment it by milliseconds or basically by seconds. But that would pretty much depend on your domain itself, which is what kind of data. So, for example, if it's legal data, then you can have a bigger context window as compared to if it's just sentences, then smaller sentences. Conversational data can be much smaller. Maintain a separate pipeline for training. So having a separate pipeline for training on the historical data versus for training on the fresh data as well. Implement data versioning, group incoming data points, which is basically more like, instead of labeling them now, what you instead do is to sort of cluster them up within these groups to be able to curate small batches of data that you can eventually use for testing as well. And this really helps to be able to optimize the inferencing speed as well. Finally, how do you keep your data fresh? Until now, I think we've talked about why data management is different, what the data management pipeline looks like, what are the key challenges, how to get some quick wins over those ones. But one of the big things, again, because these are conversational models, is we need to make sure that our data is fresh. So we have 4 techniques here. We have polling, we have CDC, we have event-driven updates, we have streaming updates. Chances are you would implement one of these techniques, or you could actually implement all of these techniques as well, or like a combination of these techniques. It would very much depend on what is essentially you're looking for. If you're looking for low latency in your application itself, then you would be looking for event-driven updates. And a lot of vector databases, I think Milvus does support event-driven updates itself. If you're looking for streaming updates, which is you have highly dynamic data sets, you would ideally look for a really good streaming solution like Apache Kafka and stuff. So that's how you keep the data fresh. Again, that's also how you would choose your vector database as well, which is whenever you're looking how to store your data, think about if it has metrics to be able to, if it allows you to be able to create your custom metrics to keep your data fresh as well and classify that. Though there are a lot of decisions as to how to choose your particular vector database, different kinds of indexing techniques they use, different kind of vectorization algorithms they use. But I think for this talk specifically, I'm limit short on time in the sense, like I think that would probably be like a longer lecture and wouldn't cover it. But you can message me for that after this. But to wrap up, I would say good data management requires automation, which is you need to automate collecting new data. You need to automate how to integrate it into the model itself, and a continuous flow of recent and relevant data. And this is like the core of how do you get high performance out of your large language models and everything that is there.
So there are a couple of questions. Before we get into questions, how can people get the slide deck?
How can people get the slide deck? I'll share the slide deck with people in the chat.
Okay.
Yeah, I'll do that. Give me 1 second.
Sure.
I need to stop sharing, and
Yeah, go ahead
then
and
I will
stop.
be able to.
Perfect.
Okay, if we go on share, so anyone with the link can access it. Copy link done, and There we go.
Perfect. And then there was and this is not something I'm familiar with, but I did a little chat GPTing. Is a pretty in-depth question about, I don't know if I'm pronouncing this right, Dora versus Lora versus Vera. And essentially, you mentioned doing fine-tuning with Dora, and so the question is, are you using Dora instead of Lora? And then kind of to clarify, it says, I forgot, according to, you tried to use Lora drop, oops, hold on, or other new version of Lora or even Vera instead of regular Lora. So I guess just could you talk a little bit about using that tool, results, and how to avoid overfitting?
So I would say the best way to avoid overfitting is, again, one is implementing everything on the data cleaning side of things, and then second is obviously using regularization. So have I used the new versions of LoRa? Not really. I'm still working with LoRa and QLoRa itself. I've not really used Dora yet. I lost the voice.
Muted. For those of us who don't have, or I mean, maybe not professional machine learning ops or data scientists, more on the data engineering side. You talked about kind of positioning the DevOps, not DevOps, data ops engineer role. What's the 80-20? Like, where should someone spend their time upskilling? Because you could spend a lot of time wrapping your head around everything. What's like the core stuff that you should know as a data engineer, not to become, a modeler, but to just expand that data engineering skill set to be able to address the needs of an LLM model being brought into your organization?
So I would say there would be three things I'll focus on. One very quick win is if you know about different indexing techniques, different vector databases do have, and why one is better than the other, different vectorization techniques as well. So if you really understand all of those things, because most of the databases that you're using will allow you to write your own custom metrics. So one is you can very quickly increase the performance of your model, increase the performance of your vector database if you know how it retrieves particular information. So that's one. Which is dig deep into different indexing techniques, different vectorization techniques for vector databases. The second thing I would say is look a little bit more into deduplication again, because even the people who do not want to gain much out of large language model applications, even then, they don't want to lose something, which is they don't want a PR kind of crisis. So deduplication is one of those techniques which comes really handy if you're thinking about how to make sure your model isn't memorizing the information. And that's the big security and compliance issue. So learning a little bit more about the techniques that we talked about and going a bit more into detail are two of those things that I would do that would put somebody very quickly at the top. And then the third thing is there are not enough people right now who know how to do cleaning on datasets for large language models. So if you do those three things, then there's a place for you that already exists within any sort of large language model team right now. You're muted.
So follow up. That was super helpful. So follow up to that, and also on early in the presentation, you were talking about how you need this dual pipeline of the data coming in. If you're not training from scratch, right? So if I'm understanding correctly, if you're doing a RAG model, you're leveraging an existing LLM model, whether it's open source or whether you're paying for it, but they've trained the language part of the model, and you're bringing in your corpus of data into the RAG. Could you review that was, I think, the second version in the slide deck that you're talking about. You still need to pay attention to, I guess the question is, you still need to pay attention to the language elements of the data.
Yeah, I mean, I guess that comes into like the evaluation side of things. I mean, not to say evaluation isn't important. I guess you can't really tell if you have good data set unless you know how to be able to evaluate the data set. So yes, I mean, that is ideal. When it comes to you talking about understanding those two pipelines really well, I think more than understanding how the retrieval and generation really happens at the architecture level, maybe understanding the metrics on how to make sure that we can measure it. And I already have a presentation out. I think it will be an O'Reilly website on evaluation for large language models that goes very much into detail on this. So I've told what are the metrics you should be looking at, what are the tools and frameworks you should be looking at, how much score should you be expecting on each of those metrics as well. So that's something you can ideally look at. Or if you message me, I'll be happy to send the slides as well.
Okay. And then last question. LLMs are a product that are built by very few big companies like OpenAI, Anthropic, etc. How do you see the broader range of companies find application areas with respect to building LLMs themselves versus using them as tools like GitHub and GitHub Copilot?
So I've already been working with quite a few banking and algorithmic trading companies that are using large language models. Though they're not using it for external customer applications, they're using it for internal trading. So for example, whenever they have lots of data which is internally recorded, which needs to be taught to any new person that comes in. They have technical documentations within their team according to which the syntax should be structured and stuff. So that's the core application that they're working on, and then doing more. Then doing also automated stuff, which is more like the chatbot stuff on a lot of dashboarding stuff. So that's one application which I've worked on. Is us as data scientists, we've really spent a very long time building dashboards, but most of the people don't end up looking at dashboards eventually. Everybody wants them, but they end up going to waste. Right. So one of the companies I was working with last year, I was doing consulting for them. What they were doing was they integrated large language models onto their dashboard to be able to answer questions automatically. And then that would send queries based on what was the person asking, and figure out similar questions. Then it does reporting automatically to the person in natural language to different people as well, because again, large language models are able to adopt to different personalities. So for a business executive, what are the things they're looking for, what is the language they're looking for, is very different to what a data scientist would be looking for from that dashboard itself. So there are quite a few applications that do already exist that companies are already implementing. So it's across the board in terms of e-commerce. One of the ways most of the e-commerce does search is they use elastic searches. Right now, I've seen a lot of companies are playing up with using large language models plus knowledge graphs to be able to replace Elasticsearch, which is still like Elasticsearch is vector search, and you can use a vector database instead, plus increase interpretability on top of it by introducing knowledge graphs, which retains the structure of the entities within your data itself. So that's what they've been doing. In terms of results on that, I've not seen anybody put it in production yet. But internally, that's work amongst a lot of aggregator companies.
Okay. Cool. Well, thank you so much for your time and knowledge. This is great.
Thank you.
All right, guys. And that's it. That's the end of our session. Thanks for coming.